products to sums. So it's something like this. We've got a product of two trig functions. In this case, it's sine and cos, and we end up with a sum of two trig functions. Now, what it basically is, if I was to expand the right-hand side out here, I'd get sine A cos B plus cos A sine B, and then the next one would go sine A cos B minus cos A sine B. So the second bit cancels and I get 2 left of the first one. So that's where they come from. It's basically playing around with those formulas. And then there's another one that goes 2 cos A cos B, which obviously comes from the cosine formula, because remember that one goes cos sine. And then also derived from the cosine formula is if you have a product of sine and sine, which also would come from the cosine one. Okay, so there's the formulas for turning a product into a sum, which, as I say, is really just a rearrangement and playing around with the compound angle formulas. So what does it allow us to do? So I've got something like this, 2 cos 5x sine x. Now, why would this be useful? I suppose if I was integrating this, it would be useful, because I could break that up into 2 sine functions, which would be easier to integrate, and we'll see that obviously later on when we're doing with calculus. So I'm going to rewrite it to match my formula. So in other words, I've just swapped the sine and the cos around, so I've got it in my head, sine cos. So it's sine A plus B, so x plus 5x, and then sine A minus B, x minus 5x. The order is important, of course, because you'll notice the second one becomes sine minus 4x. And then I'll make use of the fact that sine's an odd function, and I'll get sine 6x minus sine 4x. So it is important I go A minus B. The plus one obviously doesn't matter because you can add in any order, but the subtraction one, it's important we have it in the right form. So cos 3 theta, cos 5 theta, well, it's going to be half of 2 cos 3 theta, cos 5 theta. So now I could use the middle one. So it'll be the half of the cosine, I'll add them together, plus the cosine, I'll subtract them. So how do I remember these? If I haven't been given them and I want to use them, if we have a look at it, we know the sine cos must come from the sine formula. We know cos and sine must come from the cosine formula. Now, the sine cos one and the cos one, so the one that ends up with sine plus sine and cos plus cos, we've put the plus first. You know, now I look at this, it might have been more logical to put the A minus B first in both of those, because then you could say consistently A minus B is first, couldn't you? Because in the last one, it's important that the sine A minus B goes first, because you're subtracting the A plus B. So maybe in future years I might rewrite that. So there we go, we've ended up with a half cos 8 theta plus cos minus 2. Cos is an even function, so I'll get cos 8 theta plus cos 2 theta. So if I had to work out 2 sine 45 cos 15, well, sine 45 obviously I could do quite easily. Cos 15, well, all right, if you remembered the exact value for cos 15. But otherwise, I could use that formula and go, well, that's going to be a sine 45 plus 15 plus sine 45 minus 15. And 45 plus 15 is 60, 45 minus 15 is 30. They're both exact values. And I get the answer of root 3 plus 1 all over 2. So it does give us an alternative way of doing that, rather than having to work out the cosine of 15. Sums to products then, going back the other way. A lot more fun. Okay, so we have sine A plus sine B ends up being 2 sine half of A plus B, cosine half of A minus B. Now once again, they do come from the same formulas. It's just a rearrangement of them, but a little bit trickier to see it. So this one I remember as 2 sine half sum cos half diff. Yeah? 2 sine half sum cos half diff. So the difference. Alright? 2 sine half sum cos half diff. Yeah. Now, the cosine one, notice cosine, so that was sine plus sine, cos plus cos is essentially exactly the same, but instead of sine we've got cos. So for sine it's 2 sine half sum cos half diff, whereas in cos it's 2 cos half sum cos half diff. Notice they're both cos half diff. And the first one just matches whichever one we're playing with. Okay. That leaves us with cos minus cos. Oh, minus 2. So, well, the way in my head, again, very scary place. In my head, when I look at this, cos minus cos. When I look at that, I go cos minus cos. That's a bit different. So I know I'm going to end up with something a bit different. Instead of 2, it's minus 2. That's a bit different. And instead of ending with cos, I'm ending with sine. That's a bit different. And actually, there's no mention of cos in there at all. That is a bit different. So I know it's minus 2 sine half sum sine half diff, because it's a bit different. You can see? Look, sine 2 sine half sum cos half diff, cos 2 cos half sum cos half diff, but cos minus cos, that's a bit different. So it's minus 2 sine half sum sine half diff. So now if I want to convert a product, into a product, so I'm getting the 2, combining it into 1, cos 3a minus cos 5a, cos minus cos, that's a bit different. So that'll be minus 2 sine half the sum, 5 plus 3, sine half minus 2. Did you just say that actually works? See? But now, when I play around with this one, half of 8a, that's 4a. Half of minus 2a, that's minus a. Sine is an odd function, so I can bring the negative out, cancel with the negative, and I get 2 sine 4a sine a. You, of course, knew that was going to happen, because if I remember correctly, it's the exact same example that we did, and I've just gone back the other way. So sine oh, hang on. I didn't have one for sine minus sine. So you know what I do? I change the question. Now I can do that with a sine function. I can't do it with a cosine function, because sine being an odd function, I can change the minus sine 4x to be sine minus 4x. It's now sine plus sine, so that'll be 2 sine half sum, but when I add them together, I've got 6x minus 4x cos half diff, but when I subtract, I'll get 6x minus 4x, so I get 10x, and we get 2 sine x cos 5x. It could be useful for something like this. If I had to solve this equation, sine x plus sine 3x is equal to 0. Now I don't want to rewrite 3x in terms of sine x's. That's going to take a while, and then have to try and solve that formula. I can bring these two terms together by going, hang on, sine plus sine. So that'll be 2 sine half sum plus cos half diff. So I get cos of minus x. Well, cos is an even function. And so that's what I'm solving. And look how simple that equation is. Sine 2x times cos x is equal to 0. Two things multiply together to give 0. So either sine 2x is 0 or cos x is 0. So we're talking about boundary values here. Well, sine, that's 0 at 0, 180, 360. It's 2x. So we're going around twice. 540, 720. Divide everything by 2, so we've got our possibilities. Cosine 0 at 90 and 270. Well, actually, we've already got those answers. So there's our final solution. 90, 180, 270, and 360. So it can be handy with solving some of these sort of equations. Hang on, I'll bring two terms together, make it a product instead of a sum. All right, look, I didn't pick too many questions out of there to have a go, because as I say, technically, not in the course, okay? But, you know, they're there to use. If you know them and you can see a spot to use them, hey, why not?